We're going to go ahead and take a look at number 49 from section 3.2, which deals with quadratic functions. In this instance, we're asked to graph the quadratic, and the quadratic reads as f of x is going to be equal to x squared minus 4x plus 1. So this is your general form, and I'm going to write it right underneath it. Your general form is going to be f of x is equal to ax squared plus bx plus c. So we've seen this form before. We work with it, especially when we want to factor a quadratic or use the quadratic formula in order to solve it. So let's move from here. One of the first things that we might want to note is that the coefficient out in front of x squared, or your lead coefficient, is a positive 1. Because it's a positive 1, how will that open? How will that make the parabola open? You said upward. You are correct. Okay, so the next thing that we should do is figure out what the x-intercepts are. Or sorry, excuse me, the vertex. Let's look at the vertex first. So for the vertex, recall that you do have a shortcut here in order to find the x value for your vertex coordinate. And that would be using the shortcut formula x is equal to negative b over 2a. And recall that that negative b over 2a, those are actually the outside values that you have when working with your quadratic formula. So in this case, our b is going to be negative 4, and our a is going to be 1. This becomes 4 over 2, which becomes 2. So then this allows us to calculate our y. So in this case, our y value would be that 2 squared minus 4 times 2 plus 1. So from here we would just clean everything up. Which gives us negative 3. So our vertex will be 2, negative 3. So before we move any further, let's go ahead and get our coordinate points, or our coordinate plane set up. So our point of 2, negative 3 is situated here, and we know that the parabola is going to be opening upward, which means it looks like it will be crossing the x-axis. So this is a good tip-off then that we should look for the x-intercepts. Recall the general structure of a coordinate point for an x-intercept is going to be the value, it'll have an x value, and then the y value will always be 0. So in this case, if we take a look at our quadratic, we have x squared minus 4x plus 1. We would set that equal to 0. Like so. But notice that usually we default to factoring. We want to see if we can factor this nicely and see what points we get. In this instance, it doesn't work out that well. So you might either want to use completing the square, or you would use your quadratic formula. I will go ahead and do it by hand. Also, I would encourage you to do it by hand just to make sure that you do have that skill laid down. But you also have your technology to help you evaluate this as well. So we would actually use negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This becomes 4 plus or minus the square root of 16 minus 4 all over 2. This becomes 4 plus or minus the square root of 12 over 2. And we can continue to clean this up. This would end up becoming 4 plus or minus 2 root 3 over 2. So obviously in this case, unless you're very, very good at what you do, if you can look at that and say, well, I know 4 plus or minus 2 root 3 all divided by 2 is easily located on the x-axis, then great. But if not, what you might want to do is default to your calculator and get a decimal approximation. So that's why I'm using those, what looks like wavy equal sign, and a wavy equal sign. What I'm doing is I'm giving a decimal approximation. I know that my decimal is going to run on forever and won't have a set pattern to it, so I'm just going to round it. In this case, I'll round it to either the 10th or the 100th decimal place. So if we were to go ahead and do a decimal approximation, this would either be equal to about 3.7, or we would have about 3/10. So let's go ahead and kind of eyeball that on our graph here. So 3/10 looks like it might be here. And then we would want 3.7, so that's about here. And we would connect those values. And this is our final solution. What I want you to note, and I would suggest making sure that you make this very clear in your notes, is that the parabola is continually opening upward and outward. At no point, even maybe to the naked eye, and since I did this on a computer screen, it might look like that eventually these lines are just going to become perfectly parallel to each other. What's actually happening is they're going to be blooming outward and away from each other. So if I'm going this way, I'm slowly but surely blooming upward and outward, as is this one. It is slowly blooming upward and outward. So I guess in this case, it's the drawback of my hand in this case. Also, what I want you to note is that there is a certain line of symmetry here. If you were to kind of take the parabola and fold it where its vertex is, that's a line of symmetry because half of the parabola would lay exactly on top of the other half. Okay, these are just a quick refresher and a quick run through of some characteristics for parabolas on top of the problem. So a bonus instructional moment, so you can't get any better than that, right? So thank you very much, and if you have any other questions, please come see me.